Hi, my name is Ben. I'm a senior hardware engineer at Emesent, and today I'll be showing you our vehicle RTK solution and our backpack RTK with Trimble support. I'll be going through how to set it up, how to configure the Trimble to talk to hover map, how you can view your RTK status in Commander, and how to process it all at the end of the day in Aura. Now I'll show you how to set up your backpack RTK with Trimble receiver. Open the case and take out the things that you need. Hover map, Trimble receiver and its quick release, Emesent spacer pole, cable kit, and 360 camera if you're using it. Install the battery into the battery slot here. Make sure you clip up the sides. First we'll install the Trimble receiver. First the spacer pole and the quick release. Then you can place the Trimble receiver on top. If this is your first time installing Trimble on a backpack, take the metal plate, peel the tape off the back, and place it about 4 or 3 spaces down here. The metal plate gives somewhere for the GNSS adapter to sit while we're using it. Plug the cable into the GNSS port on the backpack. Take the Trimble cable and plug the end with a toggle on the I/O port on the receiver. The other end can go into the adapter. Then take hover map's cable, plug it into the backpack, slide on hover map, and then hover map cable. Now you can power up your Trimble receiver and set its configuration. Now I'll show you how to set up your Trimble receiver on a vehicle RTK mount. For this you'll need vehicle mount with the spacer pole on it. You'll need your Trimble receiver. It's important to note that you'll need NMEA enabled in your settings. If you don't have this, please reach out to your local Trimble reseller. You'll need a battery, your hover map, and your cable bag, which includes hover map cable, Trimble cable, a GNSS adapter, and a metal plate for mounting the adapter. First, set up the legs on the vehicle mount. Doesn't have to be perfect, as this will be adjusted later. If this is your first time setting up, take your metal plate, remove the backing, and install it. Just press down, and the tape should stick on your mount here. Install the spacer pole and the receiver. Make sure it's done up tight. Take your GNSS adapter and place it on the metal plate. It should stick with magnets. And plug in the cable to the mount. Take your Trimble cable and plug it into the I/O port on your Trimble receiver. Then plug the other end into the adapter. You can reposition this as needed. And then place your hover map in the front of the mount. and connect it with a hover map cable. The battery is installed underneath the back like this. Make sure the lights on the back turn on, and you can turn on your Trimble receiver. Now I'll show you how to configure your Trimble receiver in the web UI. Connect to the Trimble receiver Wi-Fi. This should be an open network. You shouldn't need a password. Then navigate your web browser to 192.168.142.1 and log in using username, which is admin, and password, which should be password unless it's been changed. The first settings we want to change are the receiver configuration settings. This includes antenna, which we need to change to antenna phase center, and height should be 0. Okay. Position, make sure your receiver motion is in kinematic, and your INS setting, which if you're using the R12i, you want to disable this. Now you can go into your I/O configuration. You can set up your corrections in this tab. So I'm using N-trip correction from our local government service. And to talk to hover map, you want to set your serial settings. So this is serial 1, LEMO, and the NMEA. Serial port setup needs to be baud rate 115/200. Parity and flow disabled, but that should be standard. Make sure the outputs are GGA 5 Hz, which is here, GSA 5 Hz, GST 5 Hz, and ZDA 5 Hz. You'll also want to set GSV to be 1 Hz. The rest of the settings should be standard. After that, you're right to head outside, and when it's receiving corrections, we will be able to see that in the Commander app. Now I'll show you how to mount vehicle RTK with a Trimble receiver on a car. For this project, we care about the line markings and the curb of the road, so we're going to mount it at the back of the car, so the hover map can see straight down onto the road. Make sure the vehicle mounts are secure and the legs are tightened up. Make sure the receiver and the hover map are turned on. I'll now install the optional safety tether. Loop it around and clip it onto the side of the mount. Make sure it's mounted securely. Now I'll show you how to start an RTK mission in Commander. Press non-autonomous mission and complete your inspections. This is where you'll be able to see if the RTK is configured properly. The status will show. You can continue and you can start your scan. During your scan, you can monitor the RTK status in the icon up here. Now I'll show you how to process Trimble RTK data, in this case on a vehicle, in Aura. Go Process Scan and select your data set. In this case, it was a vehicle, so we should see vehicle show up. This is from an old scan. So in this case, vehicle mount was used. So this pops up here. It says to review our CRS and receiver type. Select RTK data, process settings. Vehicle RTK was used, so that's correct. and we want to change this to R12, as that was the type of receiver we used. Our base coordinate system was GDA 2020, so we'll keep that. And we would like to reproject to NGA zone 56 and use Australian high datum. So just check those settings are correct for your own area. Click save, and we can start processing this data now. Once that's done, we can view our files. So you have your full size point cloud, your subsample point cloud, you have your trajectory and trajectory reprojected, and then you have your fit metrics. Fit metrics will show you how well the GPS reported its accuracy and how well SLAM aligned with that trajectory. So in this case, it was an outdoor scan, and we have 99% of an RTK fix, which is pretty good. We can see that 90% of the data was within 14 millimeters reported accuracy in the horizontal and 17 millimeters in the vertical. Our RTK to SLAM distance compares the trajectory of SLAM and the RTK unit after SLAM has used that data, and this will show up any sort of false reporting of the GPS, say when it's going from outside to inside or under a bridge or through a tunnel. That can mess with the GPS accuracy. So yeah, this will show you how well SLAM and RTK was aligned. In this case, we have 25 millimeters in the horizontal at 90%. And 28. Depending on your project, you might want to look at the 50% alignment or the 99%, depending on how well you want all of the area geo-referenced. You can now open your scan or your subsample scan to review how it looks, and also to then start using the data